Okay, we're live, or sort of live because we're recording. Okay, so what is this about? We are starting the first of a series of lessons about percent. Percent. Okay, so what's percent? It's a number. And it has the symbol that goes with it, the percent symbol. I'll draw it over here so it's kind of out of the way. I'll put it nice and big. How's that? There, percent. And often students know a lot about percent. They already have some understanding of percent. But now we're getting into it and we want to make sure that it's a thorough understanding. And there might be some surprises in store. What's this cool looking little thing? A P, a D, and an F with these weird double arrowed arc things in between. This one looks like a smile, doesn't it? Okay, so the triple smile PDF, what does that mean? The P stands for percent, the D stands for decimal, the F stands for fraction. Okay, so in the curriculum I'm following, a student who's just starting to learn about percent like we are now has already learned quite a lot about fractions and decimals. And one of the things that they've learned is how to convert back and forth between fraction and decimal. So that part's a review. I'm showing this here. This is really a review. Remember, 0.3 is the decimal version of 3/10. And we can convert back and forth between them. And that conversion between fraction and decimal is what is meant by this part of the diagram. The D and the F with the smile, the double arrow arc thing in between them. It means that once you know how to do your decimals and your fractions, one of the things you know how to do is to convert a decimal to a fraction or the other way around. So if I'm converting this decimal to a fraction, for instance, I realize that I can count the number of decimal digits, the digits to the right of the decimal in the number. And I see there's only one. And that means I want to put a fraction with a denominator of 10. Why 10? Because it's a 1 with only one zero. So basically the number of decimal digits goes with the number of zeros you put here. If I had 2 decimal digits, I would want to put 100. So I have a number with 2 zeros. That's one thing. And then the number that's here to the right of the decimal digit itself, that number becomes my numerator. So I can turn a decimal into a fraction very quickly if I know this. How do I go from a fraction to a decimal? Well, I can do the same sort of thing backwards. I can say, oh, okay, to convert a fraction with a 10 as the denominator into a decimal, I can write my decimal. Since the 10 in the denominator only has one decimal digit, I'm looking for just one digit to the right of the decimal, and that digit's going to be the numerator, and I have 0.3. Now, of course, I can write 0.3 or I can write 0.3. They're both correct. I usually like to show the 0. Another thing we can do is we can divide. So if we know our decimals, we know how to divide decimals. So even though the 3 and the 10, which is a division, 3 divided by 10, even though neither the 3 nor the 10 has a decimal in it, I know my students are able to divide numbers whether there are decimals or not. So 3 divided by 10 is going to look like this, isn't it? And we know how to do this. We realize that the decimal in this number would be right here. You don't usually have to show it, but I'm showing it now while I do this. And we realize 10 doesn't fit into 3. So we need to show a 0 here. And then we're asking ourselves, does 10 fit into 30? Once I have that decimal here, I put a decimal right above it for my quotient. And 10 does fit into 30. How many times? 3 times. 3 times 10 is 30. I subtract, and I'm finished. So 3 divided by 10 becomes 0.3. That's another way of doing it. There's more than one way for us to show that we understand these numbers and that we can convert back and forth between the different forms of the number. Now, all of this in a percent lesson, and this guy hasn't really talked about that P very much yet, has he? The P stands for percent. What is percent? It's another form of a number. We know the decimal form, we know the fraction form. Well, guess what? There's a third one. There's a third form of the number, which can be a percent. So We want to be able to convert, like we can do as we've proven, between D and F, between decimal and percent in either direction. We want to be able to convert between decimal and percent in either direction, or between fraction and percent in either direction. So there's a total of 6 types of conversion that we should know. It's interesting because when we only knew decimal and fraction, we only had to know 2 types of conversion. But then by introducing just one more, it jumps up all the way from 2 types of conversion to 6. But that doesn't mean they're hard. We're going to learn them the way we learned all of the other stuff before, and it's all going to be fun. Okay, what else do I want to say about this percent symbol and these things that we did, like for instance dividing? Isn't it kind of interesting that the divided by symbol looks kind of like a fraction? I know when I teach fractions I talk about this, so I'm talking about it again. The divided by symbol looks kind of like a fraction because a fraction is a division. Because 3 divided by 10 is what I'm getting out of this. That's what I did here to convert it into a decimal. It's a division. And look at this symbol, the percent symbol. It also kind of looks like a divided by symbol or a fraction. It's a little different looking, but it has a lot of these features, and it's because there's a relationship between these things. One other thing, the word percent. Now, most students learn what a percent is, and they understand it rather easily. And it's just a new word that goes with some new concepts in math. But what does the word mean? Well, interestingly, in French, this word, which we pronounce cent, but in French it's pronounced cent, means 100. So there's a relationship between what we know of this word in English, where a cent is a penny, 100th of a dollar. A cent is 100th of a dollar, and in French, cent is 100. So there's a relationship there. And if you know that, it makes it easier to remember what the word percent means. I never wrote the word percent anywhere, so I will. Percent. Percent means out of 100. And that is an important concept because we're going to learn a whole lot of things about a percent, where knowing that it means out of 100 is part of what we do. What's on my notes? I'll make sure that for this section of my lesson plan I haven't forgotten anything. I'm going to start going some examples where we're just going to work with percents and not just decimals and fractions. But yes, looks like a fraction, PDF, the smiles. Okay, the symbols. I'm going to talk a little bit about the symbols. When you have 3 numbers, I want to erase this example. So we're going to say goodbye to the 0.3 equals 3/10 example. We're not converting that into a percentage yet, but we will do it soon. And we're just going to switch to a new example. And what I'm going to get into, 25%. I like 25% as a good starting point. 25% looks like this. And we can convert it into a fraction rather easily. I'm sure it's good news for the students when something is going to be easy, because we know that percent means out of 100. So that means 25 out of 100. Well, that's kind of the language we've already gotten used to when we learned fractions. 25 out of 100. I've just converted this percent into a fraction. Because 25% means 25 out of 100, but we can write 25 out of 100. We say it English-wise and we can write it math-wise, and it looks like this. That's interesting. What do we do next normally? We look at it and we say, hey, I can reduce that fraction. So I could do that. I'm going to. If I divide it by a form of 1, and let's say I choose 25 over 25 as the form of 1 that is useful right now, 25 divided by 25 is 1, and 100 divided by 25 is 4. So I have a reduced fraction now. This is also a review, isn't it? We know how to reduce a fraction. So we know so much. We know how to take a percent and quickly turn it into a fraction. That was fast. But we also know how to reduce that fraction to give it in lowest terms. But we also know that all 3 of these versions of the number are the same. 25% is equal to 25 hundredths. And 25 hundredths is equal to 1/4. So we just have different forms of the same number. It's the same number. What's missing here is the decimal. And Of course, we have two different fraction versions of this number, this one and that one. Which one's more useful? Well, it depends on what you're doing. 1/4 is often more useful, and that's one of the reasons why we reduce fractions. So you get them to be smaller with smaller numbers, but still meaning the same thing. Easier to deal with, I guess. But right now, this is more useful, because one of the things I want to do now is also show this number in the form of a decimal. I know how to convert the percent into a fraction rather quickly, but how about converting it into a decimal? Well, that can also be very quick. And of course, that is also a review, because we've done this before. We've already worked with both fractions and decimals. So if I want to convert 25/100ths into a decimal, what I'm doing is I'm writing the 25. I'm knowing that if I have a decimal in this number, it's going to be right here. But when I divide by 100, that means that I jump this decimal 2 places to the left. And therefore I have, I'll write it like this, 0.25. I have my decimal version of the number. 0.25 is the decimal version of this number, 25%. This fraction 25/100ths, and indeed also this fraction 1/4. Now I've done all three. I turned a percent into both of the others. And I did most of this by reusing things that we already know how to do. The only new thing there is realizing how quickly I can do this, because I know that percent means out of 100. So I quickly take the 25 and I put it as my numerator, put 100 as my denominator. Just like that, we've learned so much new stuff. And the last thing I want to talk about right now is these symbols. One of the things about these numbers is, if you're sloppy about writing them, if you don't use the symbols that go with the numbers, it's hard for the person who reads it to know exactly what number it is. We know this is 0.25 and not 25 because of this decimal. So the decimal is the symbol I'm talking about when we're talking about a decimal. With a fraction, it's this bar that we have in the middle. The bar tells us, oh, okay, it's not 25,100 or something like that. We don't just take all the digits we see and make up any number we want. This fraction bar tells us, no, this is 25/100ths. We know how to read it because we know what the bar means. We know how to read this because we know what the decimal means. And here is our symbol for percent. If the percent symbol is there, it's a percent or a percentage. And we have to know how to deal with that so that we realize what number we have. 25% equals 25/100ths, or 1/4 equals 0.25 or 0.25, and the symbols are helping us to know what we have. 25% is not the same as 25. It's the same as 0.25. 25% is not the same as 25 over just any denominator. It's the same as 25 over the denominator 100. The symbols help us to know what we're doing. How am I doing for time? Pretty good. Yep, I covered everything in this first little chunk. So now we have to do some practice. Now we want to work with more percents than just 25%. We want to be able to deal with any percent form of a number, and we want to be able to convert back and forth between the three forms of the number. But our focus right now is not on this conversion between decimal and fraction, or between fraction to decimal, because that's the thing that we already know. That was a review. Our focus is on these other two smiley double arrow arc things, because it's the percent thing that's new. So we're focusing on the percent. Let's put some other percents up and go through this process and practice it. Okay, a bit of erasing. I guess I can erase most of this. I'll leave this up there just because it looks nice. And I'll leave that up there because I am going to be referring to it again. And it also looks nice. And let's just do a whole bunch of them now. And I'm going to use up a few minutes, so I want to remember not to go too fast. How about something that's not much harder? We've already seen how it works with 25%, so we have a feeling for this. So let's change it, but not very much. Let's try 45%. Oops. There, make it look neat. I'm going to put this down. I don't need to keep it in my hand the whole time. I'm just going to refer to it to take the numbers that we want to work with for our practice. 45%. means 45 out of 100 because that's what percent means. So I so quickly, immediately turn it into a fraction with 100 as the denominator. And then I can reduce it, but I don't have to. If I want to convert it straight into the decimal, well, this would be more useful than the reduced version of this fraction. Yes, it could be done. 45 and 100 have a common factor of 5. And yes, I would be able to reduce it by dividing it by 1, dividing it by 5 over 5, yes. But instead, I'm going to convert it straight into its decimal form. And how does that work again? We have the 45. The decimal would be here if it were really 45, but because we're converting this into a decimal, we're dividing by 100, which means that we are jumping this decimal 2 places to the left. So therefore, 0.45 is what I really want. That's messy. I think I need a bit more chalk up here. Okay. Or 0.45. Okay. So to convert a percentage into both of the others is really fast. And it's especially fast if we convert it into the fraction first, because this step is so easy. And then the rest is a review. So let's do some more. I won't erase yet. Shouldn't have used up so much room there. But I'll write here and see if I can do that neatly enough. My next one, again, not much harder. Just let's do one that's just different. But one of the things that makes this easy is that we have the 5. It's a round number. It makes it kind of easy to look at. 85%. Okay, percent means out of 100. So it means I have a fraction. 85 is my numerator and 100 is the denominator. And then I convert it into a decimal, and I'm kind of skipping a little bit of the step here. The decimal would be right here after the 5, but it jumps 2 places to the left, so that's going to give me 0.85. As I switch between forms of the number, I have to be careful to apply the correct symbol. The percent symbol shows me what number I have, and then the fraction bar shows me what number it looks like when it's in its fraction form, and then the decimal shows me what type of number I have when it's in its decimal form. And this becomes very fast and easy to do with a bit of practice. All of these have 2 digits. It's one of the reasons that they're easy. All of them so far have had a 5 as the second digit, just to make the number kind of easier to look at. Numbers that end in 5 are kind of, they feel easy. What do I have? Now I have next another example that doesn't have a 5 as the second digit, so I'm only changing that for now. I like to proceed with little tiny steps to gradually say, well, what if it's like this? What if it's like that? That's the way I like to approach this. I'm even going to keep this, even though it's kind of messy. I'll redraw that part. I'm going to keep that percent symbol and erase the rest and do my next example. First I have to fix that percent symbol. And my next example is 37%. So it's not a 5. It's the only thing that's changed really. It's still a 2-digit number. It's still going to be easy. The percent still means out of 100. So it's 37 out of 100. Now, all the others that we were dealing with earlier when we got into the fraction form, they could have been reduced, but we were choosing not to do it. This one can't be reduced. 37 and 100 don't have a common factor. I cannot reduce it. But do I care right now? Not really, because what I'm doing right now is proving that I can convert the percent into the other 2 forms, and this would be the most useful form anyway. And what's happening, if there were to be a decimal in that 37, it would be right here, but I'm dividing by 100, so I'm going to jump that decimal 2 places to the left, so it's 0.37. Or 0.37. Sloppy 0, but still. I can stick that 0 in if I want. Not very hard. Let's do another one. Ooh, 99%. Last time I taught this, that 99% wasn't part of my lesson plan. It was suggested by a student. So this time I decided to keep it. Okay, 99%. Because the student's doing the same thing that I try to do. That what if. Well, 99% is almost 100. It almost went to 3 digits, but not quite. So is it going to be harder? Let's see. And of course what we see is no, actually it's not harder, because 99% means 99 out of 100. And I can turn it into a fraction that quickly. And I cannot reduce this, but I don't want to anyway, because what I want to do instead is convert it into a decimal. It's going to be 0.99. So this starts to feel kind of automatic. And whenever you're dealing with two-digit numbers with the percent symbol after them, it is going to keep on feeling that way. But we still want to slow down and think about what we're doing and understand it, because we don't always have two-digit numbers. So we want to still be able to do it, even if we're given a percent that doesn't have two digits. 99 almost went up to 3 digits. We weren't quite there yet. Same procedure, nothing really that new there. So the what if gives us 99, and what if, well, nothing much if. It's fine, it's easy, it's still the same process. My next one, for some reason, the next one I chose for my lesson plan kind of stepped backwards to being a two-digit number ending in 5 again. Why did I do that? I don't know, I don't remember, but it was 15%. So all that's happened here is it got smaller. We were dealing with a bunch of numbers where the percent was a smaller number than 15. Sorry, it was a bigger number than 15. All of them? Yes, all of them so far. Okay, so with the 99 we got bigger and said what if, and now we're getting smaller what if. But it's again going to be a thing where, well, the what if is nothing really very new is happening, because 15% still will mean 15 out of 100. We're again in a position, because it is 15, that we have a common factor and we would be able to reduce it if we want, but we don't want to, because our next thing to do today is to convert it into a decimal, and it's just easier to deal with it when it's already a fraction with 100 as the denominator. I'm moving that decimal, which would be right here, 2 places to the left, so it's going to be 0.15. Okay, the reason I put that in is because the next one is 5%. Oh, okay. Does that mean that there's anything new? Well, yes, it's slightly new. But is it going to change a lot of what we do? Not really. Not really, because the new thing that we learned is still going to work the same way, and that's the only new thing we have really learned so far in this lesson, which is 5% means 5 out of 100. So that hasn't changed. It's just a 5. It's a one-digit number as the numerator. Instead of a 2-digit, but it's still percent, so it's still out of 100. And yeah, I could still reduce this. I could divide top and bottom by 5 over 5, and it would give me 1/20th. I could do that if I wanted, but I don't want to. What I want to do is I want to convert it into a decimal. And this is going to feel a little bit different, but it's not new. Because converting from fraction to decimal, we're already good at that. So how does that go again? If the 5 has a decimal, it's here, and I need to move, because I'm dividing by 100, I need to move that decimal 2 places to the left, which means I have to put a placeholder 0 here. And I end up with 0.05 or 0.05. So a one-digit number does not make it much more difficult at all. In fact, it doesn't feel like it became any more difficult, because this step still seemed just as easy as with all the previous examples. And this is where it got to be a little bit more challenging, but challenging for a student who doesn't know how to convert fraction to decimal, and that's not us. We know how to convert fraction to decimal, we've already learned that. So not a big problem. What else do I have here? Well, let's do a couple more one-digit percentages. I'll erase all of this. Let's see how I'm doing for time. What I'll do is because I want this lesson plan to be an hour, planned to be an hour, I want it to actually be an hour, but what I'll do is, if it's going to be a little short, that's where I ask students to suggest questions for me to work on. And that can be really fun. It's fun when students get involved in the lesson, but the way to do that is to type into the comments, or type into the chat, depending on what type of connection you have to this lesson. And I will look at any suggested questions and think about whether I want to incorporate them into this lesson plan. So my next percentage that I want to do is 8%. So 5 was round number, the 5 type number, so I'm not really changing it very much. It's going to be 8%. And I don't think anyone's going to be made nervous by this because we kind of already know what to do. It's going to look very similar to when we did the 5% just now. Excuse me. 8% means 8 out of 100. Can I reduce this? Yes. Do I want to? Not really, because I want to convert it into a decimal. And when I convert it into the decimal with the 8 would be right here, and I have to move it 2 places to the left. I need the placeholder. We know how to do that. So the placeholder 0 is going to go there before the 8, and when I move that decimal 2 places to the left, because I'm dividing by 100, it's going to end up here. No problem. How about 1%? That's the smallest percent I can think of right now. 1%. Is it going to be different? No. In fact, I think most of the students are probably thinking, well, it's obviously going to be 0.01 or 0.01. And they're right. So 1% means 1 out of 100. And that is going to give 0.01 or 0.01 because the decimal with this one would be right here. And if I move it 2 places to the left, I need the placeholder 0 so that I can do that. So it's looking the same as the 0.08 and the 0.05 before it did. Nothing really that crazy has happened. But, now I have some other ones that look kind of interesting. Looking at the time. Oh yeah, I'm doing pretty good for time. I'm going to erase, and we're going to do another what if. Here's one. 150%. And what does that sound like? When we think about the way the word percent is used commonly in the English language, it sounds like someone's exaggerating. It sounds like the athlete who says, I'm going to leave 150% out there on that field. Yeah, they want to exaggerate. I don't just leave 100%, I leave 150%. That's kind of cute terminology. But does it make very much sense? No, it doesn't make much sense because what does 100% mean? 100%. We have to talk about 100%. We didn't do 100% yet, did we? We will. 100% means all. Means all of it. It means in fraction terms, 1. When you have a fraction, let's say it's the pizza, and you have 8 slices remaining out of a pizza that started with 8 slices, well, that means 1. It means we have a whole pizza. Whole, that word whole is useful. The whole pizza is because this is equal to 1, and 1 is the whole. Well, in percentage terms, 100% is the whole. 100% is equal to 1. That's interesting. And we'll do 100%, but we're going to go back to do the 150%, and this isn't here just as an exaggeration. It's here because a number like 150% has its uses in math. It's not just there for exaggeration. How do we do this though? Again, it's the same. It keeps on being just as easy. 150% means 150 out of 100. So what I get is an improper fraction. I get a fraction that is equivalent to a decimal that is greater than 1. Because whenever you have one of these fractions where the numerator is greater than the denominator, it ends up, when you convert it into a decimal, which we all already know how to do, it turns into a decimal that's greater than 1. So we're not too surprised. And this thing out of a percent meaning out of 100 is just as useful as always. So now I need to convert it into a decimal. I'll show that a little bit more slowly. I'll write the 150. If the 150 had a decimal, it would be here. Dividing by 100 means I am jumping that decimal 2 places to the left. So because this number is greater than 1, jumping the decimal 2 places to the left doesn't get me to the end of all the numbers I have, and it's equal to 1.5. And I don't have to talk to myself about whether I put a 0 before the decimal or not, like I do with those other ones that are all smaller than 1, because I have a 1 there. I don't need to put a 0 there. There's a 1 there. So 150% is equal to 1.5, which is equal to 1.5, which is equal to 150 100ths. But of course, if I were to reduce this, it would turn into 3/2. And if I were to convert that into a mixed number, it would be 1.5. So all stuff we've seen before, and it applies to percent as well as to decimal and fraction, and we're not surprised because it has to. These are just three different forms of the same number. Percent, fraction, decimal. They all mean the same thing. So, in terms of pizza, this is 1.5 pizzas. That's 1.5 pizzas. Makes sense. 150 over 100. Well, if you have your pizzas cut into 100 really skinny slices, yeah, you could have 150 really skinny slices out of pizzas that are divided. Well, you would have 1.5 pizzas. And 150% in terms of pizza means 1.5 pizzas because the number really means the same thing. There's just different ways of writing down the number. Okay, cool. So these 3-digit ones, we can do them. We didn't have to stick with 2-digit. We tried 1-digit, we were able to do that, that wasn't so hard. Now we're trying 3-digit and it works. It still works, all of the techniques still work. Everything makes sense in the same way that it already did. And that is good news. So, some more 3-digit numbers to practice with though. And of course 150, I chose 150 because it's kind of an easy seeming 3-digit number. It's a very round number, it has a 0 at the end, etc. How about 180%? Oh, messy. That's a little messy too, but I'll keep it. Okay, 180% means 180 out of 100. And then when I convert that into a decimal, the decimal is moving 2 places to the left, but it's a 3-digit number, so it's going to be 1.8. Do I want to write 1.80? Well, I can if I want, because 1.8 and 1.80 mean the same thing. We've already talked about that as well. When you get to the end of the non-zero digits in a decimal, and you're to the right of the decimal place, you can stick as many zeros on there as you want. And in fact, see, I can do this if I want. I haven't changed the number. But in fact, I can also put a bunch of zeros here if I want. I haven't changed the number. It makes more sense to just call it 1.8 because it's less cluttered. But this number is equal to that number, which is equal to that number, which is equal to this number, which is equal to 18/10, or 1 8/10, or 1 4/5. Oh, I'm being a show-off now. Yes, of course, we can do all sorts of things with fractions, but that's a review. Percentage is what's new. So, without getting all cluttered, let's do a few more. And this had a 0 here. It's kind of a round number. Let's do some that are not quite so round. So my next one is 124%. This chalk is getting to the end. Fortunately right here I have a brand new whole piece of chalk. There's that whole number again. That whole number comes in handy in math even when you're choosing chalk. What was my number again? 124%. Nothing's changed. This isn't going to be harder. It's a bit of a what if. Okay, what if that's not a 0? No problem. It means 124 out of 100. We have our fraction. We can reduce this, we could convert it into a mixed number, but we don't want to. We want to convert it into a decimal, and that means it's going to be 1.24, isn't it? Because the decimal in 124 would be right after the 4, and we're moving it 2 places to the left because we're dividing by 100. How do we know how many places? We count the zeros in this. There's 2 zeros, so that means I'm moving it, the decimal 2 places to the left. We're used to this. This is all review. 1.24 is going to be the answer. This is fun. How about if it's even bigger than something, a 3-digit number that's bigger than 200? How about 250%? Okay, I know what you're saying. You're saying it's not going to be any harder, and you're right. But we're just going to do a few 3-digit ones just to prove it. 250% is equal to 250 out of 100. And when I convert it into a decimal, that's going to give us 2.5. Easy. How about 350%? Okay, this is starting to get really repetitive, isn't it? All the students know exactly what's going to happen. 350% is equal to 350. Oops, that 5 is too messy. 350 out of 100, and that's going to turn into the decimal 3.5, isn't it? And like I say, this does become automatic to students once they've practiced it enough, because they understand it. So they see the number and they know by how many digits there are what's going to happen. And that's interesting, because those students who are good at this, who do this so quickly, after a while, they may not realize that they counted these digits, but they did, because they wouldn't have been able to do it correctly if they weren't aware of how many digits there were in the number. Interesting. Interesting how our minds work and how our memories work, that we're able to do something so quickly that we didn't realize there were steps we were doing. But that happens, and it happens a lot in math. Okay, let's do a few more. $470%. So the numbers are getting bigger, but the challenge isn't really getting bigger, because this is just going to be 470 over 100, and when I convert it into a decimal, it's going to end up being 4.7, because, well, we know why that happened, so we're getting good at it. Try and do one that seems harder. 563%. No problem. Now this one could have been reduced when it was in fraction form, but this one, 563 out of 100. No, I cannot reduce this. I could convert it into a mixed number, but I don't want to, because what I want to do is convert it into a decimal, and it's going to be 5.63. That decimal would have been here, and it moves 2 places to the left. Yep, the procedure works. I trust it. I'll do a few weird ones that are often suggested by students. And students are doing that same thing. They're doing that what if. But sometimes you say what if when you're planning something yourself. Sometimes you say what if when a teacher is giving you all sorts of examples. But wait, teacher, what if this happens? Okay, a 4-digit number. Let's do a 4-digit number. 1,000%. 1,000%. Now, if this is an exaggeration by an athlete, that's a really big exaggeration. It means 1,000 out of 100. And yeah, we can reduce this, and we can convert it from the improper fraction form into a mixed number, or perhaps a whole number. But what we can also do is just go straight into the decimal form. 1,000%. Well, the decimal would be here. See, the what if makes me slow down. Because, okay, it looks a little different. Slow down. What do we do? That decimal in 1,000 would be right there, but if I move it 2 places to the left, it would end up here. So this is 10. And of course, if I want, I can write 10.0, because 10.0 is equal to 10. 1,000% is equal to 10. So when someone asks you, how many fingers do you have altogether on both hands, you can say, I have 1,000%. And they'll, why didn't you just say 10? And they'd be right, because, really, just answer the question in the clearest way possible, 10. But if you said 1,000%, you would not be wrong. And that's kind of interesting. Okay, but 1,000%, is that a little too convenient with all these zeros? How about if we have 1,200% or 1,200%? Is it going to be harder? We already know. No, it's not. It's going to be 1,200 out of 100, and therefore it's going to be 12, isn't it? Or 12.0. But I think I'm just going to write 12. Because 1,200 divided by 100, yes, that would be 12. Because 1,200 divided by 100, we could do canceling and cancel a 10, and then cancel another 10, or cancel 100. You can describe this so many different ways, and we'd end up with 12 over 1, which is equal to 12. All the numbers make sense. All the numbers translate back and forth from all 3 forms now. We can do all of these transformations, can't we? Let's make sure by practicing a few and seeing if we can find some that don't seem so easy. But I am going to do 2 more percentages first. Two very important ones. One of them we talked about already. I'm amazed it took me so long to get around to this. 100%. Well, 100% is the whole. It's like in fractions when you end up with a 1. 100%. Is that equal to 1? Well, if it's the whole, it should be equal to 1 because the whole in the fractions is equal to 1. But let's just do what we got used to doing in this lesson. 100% must be equal to 100 out of 100. And yeah, when I move that decimal 2 places to the right, it's going to give me 1. Or 1.0 if I want. And I can also do that canceling. I'm going to cancel 100. And I have 1 over 1. It's equal to 1. The whole, the idea of the whole. How is that useful? Well, the whole, let's say you have, that's a pretty good pizza. But is it a pizza? Do I want it to be a pizza? Not really. Let's say you have, this is just a circle graph. You have a group of kids who are in 4th grade, 5th grade, and 6th grade. And 50% of them are in 4th grade. And I don't know if I drew that back well, but we'll say 20% of them are in 5th grade. So how many of them are in 6th grade? You probably have already answered it because you already understand the concept of the whole. But a way of answering this is to say, well, the whole circle graph is 100%. And if I subtract the 50% of 4th graders, and also subtract the 20% of 5th graders, 100 minus 50 is 50 minus another 20 is 30. That equal sign is too sloppy. So the answer is that 30% of this whole group of students are 6th graders. So I was able to figure that out because I know that the total has to be 100% because the whole group is 100% of the group. And of course I could write this like this instead. 50% plus 20% is 70%. So therefore I could just say, oh, well, since these 4th and 5th graders total 70%, I can just do my subtraction in a single step, and I get the same answer. Bit more chalk, please. So the idea of the whole is useful. 100% is extremely useful. Because when you know a whole bunch of the things that make up the whole, all of them except one, you can, if you know percentages, if you know the numbers in the form of percent for all of those things that make up the whole except one, you can subtract from 100% to figure out what is the percentage that it was missing. And the percentage that was missing was the percentage of 6th graders from this little word problem. I guess I could call it a word problem. And 30%, and of course we also know, well, 30%, we can convert that into 30 over 100 and into 0.3 because we can just apply the skills that we just applied. Now, which one's the most useful? It depends. It depends on what you're talking about. I like the percentage for this type of situation. 30% of the students were in 6th grade. It's clear. When you say 0.3 of the students were in 6th grade, well, it's true. And if you say 30/100ths of the students, that's true, but people are going to think, oh, does that mean there were exactly 100 students? Because we don't actually know. In this situation, we don't know how many students there were. They didn't tell us how many students there were. They did tell us what percentage were in 5th and what percentage were in 4th, and we were able to figure out what percentage were in 6th without even knowing how many students there were. That's kind of interesting too. The power that we get when we learn things in math. Okay, one more interesting and different example. A lot of erasing for this one. I like that little 4th grade, 5th grade, 6th grade example though. I did not actually have that in my plan. I sort of improvised it, but I'm glad I did. Okay, so what about 0%? Yes, out there somewhere there's a student who's typing in, what about 0%? Because the students are doing the thing that the teacher likes to do, which is to ask those what if questions. But we will realize quickly we know the answer. Because as soon as we apply our knowledge that we only knew knowledge really in a way that was given in today's class, which is 0% means 0 out of 100, we realize, oh yeah, we saw this before. We've dealt with fractions where the numerator was 0. Someone asked that what if question during the fractions unit. So 0 out of 100, and that is going to be 0.0. I guess that's the most clear way to express it in the form of a decimal. Or I guess you could just say, well, technically, I'm expressing it as a decimal when I say 0. In fact, technically, this number 0 is expressing all three of these. That's interesting. And there's only one thing left to do, which is to prove how easily distracted we all get, including teachers, and to admit that there's nothing wrong with that, to admit that that looks kind of like a face with great big eyes. I'm going to put some happy eyebrows, and I guess I seem to have put a part in the hair. So okay, I got distracted. I'm going to stop being distracted. I'm going to get back into my lesson plan. This is even the wrong side of the page. Okay, so I got through all of those suggested percents, and we tried everything. We tried all the what ifs we could think of, and there's only about 14-15 minutes left in the planned lesson plan. So what do I want to talk about next? Oh, I see what I want to do. Okay. I'll erase this beautiful smiling face. And I'll mention that something that happens in math, but I'm not really making us do it right now because it's still too near the beginning of this percent unit, is what if you have an operation like 25%, let's see, times 1.8 times 2/5. What we have here is a mathematical calculation where we have a mixture of percent and fraction and decimal, all of them are there. And what do you do? What do us teachers call this? I call this a mess, a big mess. And as soon as I see it, I want to do something, and that's all I'm talking about. I'm not going to answer this question. It is answerable, and I'll leave it to you to answer it if you want. And type your answer into the comments/chat, and we'll see. But I think it's very doable, because the answer to the question I'm asking, how do we deal with this, is convert them all into the same form. Don't try and work with multiplications where you have a mixture of percent, decimal, and fraction. Just get them all into the same form, and we know how to do this. This is what we've been doing all through this class. We were able to convert percent into either decimal and fraction. We already knew how to convert a decimal into a fraction or a fraction into a decimal. So get them all into the same form. And as soon as they're all in the same form, then it's much easier to see what you're doing, and it's easier to get through the question without making a mistake. So I'm not solving this one. Maybe next week. What I am doing is making sure that we covered all of these double arrow arcs or smiles, because we've done a whole lot now of percent to fraction, and although we kind of did it in a roundabout way, we were converting percent into decimal as well. We tended to use the fraction as a middle man, I guess. So what I was doing, I guess, would be expressed by going in a circle like this, not all the way, going like in a clockwise around. I would convert my percent into a fraction, but then I would convert the fraction into a decimal. I have all of them, so I can use whatever method I want to convert between one and the other, so long as I can. So that was a bunch of the new stuff, was to go from percent to decimal and percent to fraction. We've done it, but have we done enough decimal to percent? That direction. Have we done enough fraction to percent? that direction. So let's try something. So in the decimal to percent, I'll do this. In the decimal percent category, how about we do 0.25? Okay, so what am I doing? I'm doing the same stuff. I'm just doing it kind of in a different order. 0.25. Oh, I remember when you have 2-digit percent, it always ends up being 2 decimal digits with a 0 to the left of the decimal. So I can sort of say that, well, doing that backwards, and of course I started with 0.25, which was in my very first example of the whole lesson. 0.25 is equal to 25%. So how am I doing that, showing it backwards? I'm moving the decimal 2 places to the right to convert from a decimal into a percent, but this only will make sense if I remember to apply the appropriate symbol, which means that even though I was working with that decimal, I didn't end up writing down the decimal here because I didn't want it to be confusing. I know I've turned this into a percent, so I have to put the percent symbol, because if I don't, I just turn 0.25 into 25, and that's not true. But 0.25 is truly equal to 25%. So I can go from the decimal to the percent, and of course I can go to the fraction, but that's a review. Now it's a double review, because going from decimal to fraction is something we already knew before this lesson started, and going from the percent to a fraction is something we've done a whole bunch of times already today, so I don't really have to show it. I'll just do another decimal. So I started with 0.25. What if it's not 0.25? What if it's something else? What if it's 0.15? Same thing. That decimal moves 2 places to the right, which means it's going to be 15, but I have to put the percent symbol for that to make sense. How about 0.5? Uh-oh, slow down. This is a what if. It's another one of those what ifs. Now it's not 2 decimal digits, it's just 1. But because I have to convert decimal to a percent, I have to move the decimal 2 places to the right. I have to jump it 2 places to the right. Oh, this is a good time to slow down. It means I need a placeholder 0, and I ended up with 50%. And yes, 0.5 is equal to 50%. So sticking in the placeholder 0 might make that easier. I'll do a few others really quickly because I think we're already good at this, because it doesn't really feel like we're doing anything that's very new. But to go from decimal to percent, notice I'm not going from percent to decimal because we were already doing that before. To go from decimal to percent, how about 0.05? Ah, we had 0.5 and it gave us 50%, but this is 0.05. So when I move the decimal 2 places to the right, it's giving me 5%. Slow down and be careful. The 0.05 example gives 5%, and the 0.5 example gives 50%. That's pointing at something that's not there anymore, but that's what it did. Should have left that one up, I guess. Interesting. So if you go too fast, you could mix those two up. You could turn 0.05 into 50% by accident, and turn 0.5 into 5% by accident. So slow down. Whenever things get a little tricky, slow down. But we were able to do that. 0.7. Well, that's similar to 0.5, isn't it? So I'm moving the decimal 2 places to the right, so it's equal to 70. I need a placeholder 0 there. And don't forget to write the percent. I don't really have to show that 0, but I do have to show that percent symbol. Any more? I have 3 more. I'll do all 3 really quickly though, because we're good at this. So I'll write all 3 of them at once, and then we'll do all 3 of them all in a row. How about 0.02? How about 1.63? How about 2.8? Move this 2 places to the right, and it leaves us with 2%. We're not surprised. We saw what happened with 0.05. Move this 2 places to the right, and it's going to leave us with 163%, which makes sense when we think back to what put that 1 there when we were going in the other direction. Well, this makes perfect sense. When we move this 2 places to the right, we need a placeholder 0, and we have 280%. This is cool. This is fun. I am running out of time though. So I had a little chunk of stuff down here that I'm not getting to in this lesson, because I still haven't done from fraction to percent, I guess what I should have done here was just show it like that, right? Because all I did was decimal 2%. I didn't go from percent to decimal because we've already done it. So now I'm going to go, and I fixed that just in time to erase it, I'm going to go from fraction to percent. So that's this arrow over here. And again, I'm only putting the arrow up on that side because we already know how to go to percent, from percent to fraction. In fact, that was really fast to learn, wasn't it? So fraction to percent, let's do some. 1/4. Whoa, whoa, whoa. That doesn't have 100 as a denominator. It doesn't even have 10 as a denominator. Slow down. Wait, this will be easy if I make that denominator be 100. And that's something I know how to do because I know how to expand fractions. So I'm multiplying top and bottom by 25. I'm multiplying by 1. But this form of 1 that I know will give me what I want because 4 times 25 equals 100. But I have to do this as well. So 25 over 100. And now that I've done that, I can say, oh, out of 100 means, this means 25%. And I'm not just doing that because I remember, because I already did 1/4. I already did 25 hundredths. I did that as the very first example. That's why I wanted to start with it. But isn't it interesting? You adjust your fraction if you can so that it has 100 as the denominator. And then it very quickly turns into a percent. And it turns out it's not hard after all, is it? But let's do a couple more in our last little bit of time. 3/4, why not? This isn't going to be very different, is it? I'm going to end up multiplying by this version of 1 again, and it's going to give me 75 out of 100, so therefore it's 75%. That fast, that easy, it is fun. Sometimes when things are easy, they're fun. So 3/4, okay. How about 1/5? 1/5. No problem. We can make 5 turn into 100 by multiplying it by 20. So therefore, the version of 1 I want is 20/20ths. 5 times 20 equals 100, and 1 times 20 equals 20, and 20 out of 100 means 20%, because that's what this percent, what that word percent means. Wow, that was fast. Okay, that wasn't hard. So a lot of these are not hard, but let's try and make one that's a little harder. Let's see, what do you do when it's not so easy to turn your denominator into 100? So this example is 7/8. 8 times what equals 100? That's a little awkward. There's an answer. But unfortunately, when we're doing this, we get used to its fractions. So we don't expect to stick decimals inside of fractions, and that can be confusing. Because 8 times 12.5 is equal to 100, but I'd have to put 12.5 over 12.5 as my form of 1, and I could do that. But I decided instead, I think, what if I do this? Well, then I get 70 over 80. And I did something, but it's not really necessarily making it easy to convert this into a percentage. And what if I do it again? That turns into 700 over 800. Why am I doing this? I'm doing it because 8 was awkward. 80 was still awkward. 800 is starting to feel like it might not be so awkward because 800 is a multiple of 100, isn't it? I want that to be 100. Well, now what do I do? Divide by 8. But it has to be 8 over 8. I have to divide by 1. And the bottom is easy. 800 divided by 8 is 100. I did it. I finally got it. But 700 divided by 8 is going to give me a decimal. And we're going to have a decimal inside a fraction, which is something that a lot of students are going to think, no, don't put a decimal inside a fraction. No, please. But I'm doing it. Because 700 divided by 8 happens to be 87.5. Why do I want to do this? Because, well, even though there's a decimal in it, now that I know it's a fraction over 100, I can convert it into a percentage. 87.5% actually is my answer. 7/8 is equal to 87.5%. So if a teacher was weird and decided to make a quiz out of 80, 70 out of 80, that's your grade. It's good. You can tell it's good, but what does it mean? I could convert it into 87.5%, and then it's, oh yeah, okay, yeah, 87.5%, that's really good. And also it even rounds up to 88%. Bonus. But what else could I have done if I didn't want to show all of these fraction-looking steps? I could have just said 7 divided by 8 in the calculator. And it would give me the decimal version of that fraction. And the decimal version converts into a percentage rather more gracefully. Remember moving the decimal 2 places? Oh, okay. So that seemed like it was kind of long. This didn't seem so long. Of course, I used the calculator. And yes, we're allowed to use the calculator once we move to the percent unit. There's one other thing I could have done, and it's the last thing I'm going to mention because I am out of time. I'm going to mention that I actually know how to do this. Because we were dividing decimals recently, and so we all know how to do it. And there's no decimal in either the 7 or the 8, but in order to finish this, I'm going to have to use the decimals. So the decimal would be here, which means in my quotient it's there. And then I can put a 0 here, and I can say how many times does 8 fit into 70? 8 times 8 is 64. Okay, I need another 0. How many times does 8 fit into 60? 8 times 7 is 56. I'm running out of room, so I'm going to erase this, even though I really didn't want to erase it. And 60 minus 56 is 4. Not finished, I need another decimal, but 8 fits into 40 a beautiful 5 times. And I'm back to the same place I would have been if I used the calculator, it just took longer. So 7 divided by 8 is 0.875, but when we want to convert the decimal 0.875 into a percentage, we move this 2 places to the right, so it's 87.5%, which we knew. It was the most complicated one, but it still feels easy. I hope it feels as easy for you as it does for me. And that's the end of this week's lesson, and I enjoyed that. I hope you did too.